So as you could see on the previous diagram, you have those two major lymphatic ducts that all the other vessels will flow into. The majority of the body is going to be drained by the thoracic duct. The lymphoid cells, there are different types of cells involved with the lymphatic system. You have macrophages, which are specialized to carry out phagocytosis. They're also going to be involved in activating your T lymphocytes. The dendritic cells also help to capture antigens and bring them to the lymph nodes, so they're working to recognize these foreign cells as well, these non-self cells. The reticular cells produce a reticular fiber network. It kind of looks like a scaffolding network in the lymphoid organs. And on the scaffolding within all these fibers is where the macrophages and dendritic cells and your T cells can hang out to be able to basically play like surveillance and monitor any foreign cells, whether it's bacteria, whether it's viruses, that are passing through there, and recognize them and then be able to attack and destroy them. The lymphoid tissue is extremely important because it does help to provide a site for storing and then activating and having your lymphocytes proliferate. When they are exposed to a foreign substance, they go through a proliferation stage where basically they're producing lots of clones to be able to fight whatever the infection is. So it provides a nice surveillance spot for your macrophages, like I say, to be able to recognize foreign tissue. The reticular connective tissue does dominate most of all the lymphoid organs except in the thymus. So like I said, those macrophages live there and the lymphocytes are also going to be there. Now some of the lymphocytes will eventually leave and kind of go on patrol throughout the body. The lymphoid follicles or nodules are scattered throughout other organs. They don't have a capsule. They are associated with other organs, as I said. The main lymphoid organ are your lymph nodes. They tend to be clustered along the lymphatic vessels so that the lymph is flowing through the vessels. Then they're going to flow through the lymph nodes where they're going to be filtered. There are clusters of them, as I said earlier, in the cervical, axillary, and inguinal area. They're filtering that lymph. They're also going to be involved with helping to activate your immune system. On this diagram, you can see a cross-section of a lymph node where you'll notice you have the afferent lymphatic vessels that's bringing the lymph towards the lymph node. It's going to be passing through, that lymph will pass through the cortex area, through all the sinuses, through the medulla area, which is in the innermost area. The cortex is on the outer area, and then eventually drain out of the efferent lymphatic vessel. So while it's in that lymph node, that's where it hopefully is going to be coming in contact with the macrophages and the lymphatic cells. So I said that lymph enters in through the afferent. It's going to move through those open areas, which are the subcapsular sinus areas, and then pass from the cortex to the medulla and finally exit through the efferent lymphatic vessels. Once again, as you can see here. Buboes are simply when the lymph nodes have so much fluid going through them, they're working to try to clean out infection, and they start to swell and they become inflamed, they become swollen. They're often very tender to the touch, and this can be used as a means to try to help diagnose, number one, that you have an infection. Bubonic plague, that's where the name gets its classic name from, is because of the formation of the buboes. Other lymphatic organs are the spleen, the thymus, your tonsils, and then you do have aggregates of lymphoid follicles, such as the Peyer's patches that are associated with the small intestines. You have the appendix, and then the mucosa-associated lymphatic tissue, or MALT. This diagram is showing where you have your tonsils, the thymus, the spleen, those Peyer's patches, and your appendix. A splenectomy is when you remove a spleen that has ruptured. The capsule around the spleen is fairly thin, so Unfortunately, it does not have a whole lot of protection, so a severe blow can cause it to rupture. It has a high blood supply to it, and so that blood will spill into the peritoneal cavity. Now, oftentimes, the spleen can repair itself if the damage is not too extensive. Years ago, they used to kind of automatically do the splenectomy, and now they've realized that if you leave it in, if possible, let it repair itself. That would be the best thing. If it does have to be removed, then the bone marrow and the liver will take over the functions of the spleen. So you can certainly survive without it. The tonsils, you have four main sets of tonsils that are named according to their location. You have the palatine tonsils, the lingual tonsils, the pharyngeal tonsils, which are also known as your adenoids, and then the tubal tonsils. The Peyer's patches, as I just mentioned, are located along the wall of the small intestines. The appendix is right at the junction of the small intestines to the large intestines. Both of these are involved with helping to destroy pathogens. You want to prevent anything that has been ingested and is passing through the digestive system. You don't want it to be able to pass through the walls of the intestines and gain entrance and penetrate into your body. The MALT, or mucosa-associated lymphatic tissue, these are small areas of tissue, lymphoid tissue, that's found in the mucosa areas of the genital urinary organs, along the walls of the bronchi, and also along the digestive tract. Once again, this is trying to help protect areas where you have openings to the exterior and you don't want something, once again, to penetrate into the body.